Africa Enlightenment Center, Religious, Political, and Social Enlightenment.
The topic is physics being misrepresented and misunderstood. We've seen many times already how much biology is misrepresented and misunderstood by creationists. And we don't hear too much about how physics is actually being misrepresented as well by theists, and not only theists, but also spiritualists. There's 15% of the nation right now that does not belong to any church, and a steadily rising number, especially among young people. So, they're the ones that are going to survive as the rest of us die off. But of that 15%, maybe only half are willing to call themselves atheists. The other half still have a tendency to think that there must be something out there, even if it's not the Judeo-Christian Islamic God, it must be something. They have been pretty much sold a bill of goods by the so-called spiritualism, the New Age movement. And so I'm going to also talk a bit about that, because the claims there are based on physics also, based on quantum mechanics. So let me begin. So here are the claims that are being made. First, that the eternal universe is mathematically impossible. You'll hear this from William Lane Craig in particular in his debates. And I've heard other debaters use the same argument, other theist debaters. The second claim is that the universe began with a singularity. Third is that the universe is fine-tuned for life, in particular human life. And that quantum mechanics says we can make our own reality. Now let's start with the eternal universe, the question of the eternal universe. Of course, we know that our universe began with the Big Bang. However, the current thinking in cosmology is that our universe was not the only universe. There's others out there. Our universe could have come from an earlier universe. In other words, the universe is eternal. That's always been pretty much the scientific teaching, that the universe didn't have a beginning, that it's eternal. Now, Craig and others argue that the eternal universe is mathematically impossible, because if you see in this picture here, if the universe started out at infinite time ago, it would have taken an infinite time to reach the present, so we would never reach the present. That's the argument, and believe me, I hear this argument a lot, and it's just wrong. Because a mathematician will tell you that an eternal universe is possible, because the way I like to put it is that an eternal universe didn't have a beginning, not a beginning an infinite time ago. You just go back and back and back in time, just like, think of going forward in time. Just count the ticks on a clock. You keep going forward, and you never reach infinite time. There's no such thing as infinite time. There's no such thing as an infinite number. There is no number equal to infinity. And when we use infinity in science, we really mean just a very big number, or a number that is endless. And that's what we mean by an eternal universe. It always existed in the past, and it will always exist in the future. Even when there's no stuff left, time can still be defined. So no matter how far back you go in time, it was a finite time to reach the present. So that takes care of that issue. And since I have to also be entertaining, let me mention something in passing, and that is that I heard that the Vatican is trying to modernize, come into the 21st century, so they've designed a new communion wafer that has only half the calories and a third as much fat. They call it, "I can't believe it's not Jesus." Anyway, back to the universe. The theologian will tell us that, such as William Lane Craig, will tell us that the universe began with a singularity. What's a singularity? A singularity is an infinitesimal point in space of infinite, again, these are the words infinite again, infinite density. And this is the kind of picture I'm going to show you now in several places. It's a space-time diagram. Time is the vertical axis, and space is indicated by these two axes. Now, of course, space is three-dimensional, but we're showing a projection of it onto two dimensions, all right? So at any given time, the universe is a circle rather than a sphere, let's say. That's a projection of the sphere, is a circle. So here's the universe at some time, and it starts over here at time t equals 0, and the early part of the universe is an exponential expansion called inflation. So this is an exponential curve here until that stops. I won't show it any further than that. And the universe then is moving along this time axis. And then back in 1970, Stephen Hawking and Roger Penrose derived a theorem. They derived a theorem based on general theory of relativity, Einstein's general theory, that said that the universe had to begin with a singularity, that infinitesimal point of infinite energy density. And Craig and other theologians have argued that that had to be the beginning of time itself, so that the universe had to have a beginning. And of course, I was trying to argue that earlier that there's an eternal universe, and they, of course, don't like the idea of an eternal universe because if you have an eternal universe, you don't have any creators. So you have to have a creator to be consistent with certainly Christian and Islamic and Hebrew theology. And so the claim is that that had to be the beginning of time itself. The universe had to have a beginning, and that was our Big Bang occurred at that point. However, that was based on a theorem that was derived in 1970, and since that time, in fact, already, almost 30 years later, prior to now, that is to say, Stephen Hawking, in his book, Brief History of Time, says that the universe didn't have a singularity. It wasn't that he and Penrose had made a mistake. Their calculation was correct as far as the assumptions were concerned. They assumed just the general theory of relativity, but they didn't take into account quantum mechanics. And quantum mechanics says that there's no time that you can define smaller than the Planck time, which is 10 to the minus 44 seconds. And so the universe didn't begin with a point. It began with this little region in there of Planck dimensions. And so what about the Big Bang? Well, here's a possibility, at least. The universe expands from some region of chaos in here. This is all quite reasonable. And it actually, our universe could have tunneled. There's a process called quantum tunneling that we've known about for 50 years and is well confirmed. Quantum effect that you can walk. I could walk through that wall. There's some probability if I walk into that wall, I'll walk straight through it. It's a very low probability on the macroscopic scale, but on the quantum scale, on the subatomic scale, that probability becomes fairly large. And so here we're working at these small distances in times. They're working at the quantum level, and there could have been a tunneling from an earlier universe. And this scenario has been worked out completely mathematically. I've worked it out in a book I wrote called the Comprehensible Cosmos. I've written so many books I forget the names of all of them. Now, so the universe didn't have to have a beginning. That's the second conclusion, despite the claims of theologians. And while I'm talking about the Vatican, that reminds me of another story. This one goes back. You may have heard this one. It goes back to the time when Kentucky Fried Chicken was KFC was called Kentucky Fried Chicken, and Colonel Sanders was still alive. And the story is that he called the Pope one day, and he said, "I'll offer you $1 million donation to the Vatican if you'll change the words of the Lord's Prayer to read, 'Give us this day our daily chicken.'" And the Pope says, "Oh, I can't do that. I mean, that prayer was given to us by Jesus on the Sermon on the Mount." And so Colonel Sanders says, "Well, what about $2 million?" And well, I don't know. I mean, the Pope says, this is a tradition. People have been praying this way for 2,000 years. And Colonel Sanders says, "Well, okay, let's make it $10 million. So the Pope says, "Okay, I can't turn that down." So he makes the deal with Colonel Sanders. Next day he calls together a meeting of the College of Cardinals, and he says, the Pope says, I've got some good news and some bad news. The good news is that Kentucky Fried Chicken is going to donate $10 million to the Vatican. And so after the applause dies down, one of the cardinals yells out, what's the bad news? And he says, well, the Pope says, the bad news is we've lost our Wonder Bread account. At least I'm trying to be entertaining after all these. I think JT and his colleagues pick speakers for their entertainment value at this meeting. Well, they also have a lot of good things to say. But I don't want to downplay that. Anyway, so the next step is that the universe is fine-tuned. Right now, I would say this is the most important statement, important issue in the intellectual debate between theists and atheists. It's not evolution. Evolution's pretty much established scientifically. Sure, there's still fights in the schools to deal with, but this is an intellectual battle that has not been won yet by the non-believers. Because most non-believers don't know the answer to it, and that includes a lot of the people who speak. I've heard Christopher Hitchens and others debate theists, and when the theists bring up this subject, the fine-tuning, they don't know how to answer it. Not just Christopher, but the only one out there who knows how to answer is me. Well, maybe a few other physicists, but the other physicists keep their mouths shut, so that's too bad. I think they have to start speaking up. Anyway, let me give you the argument. Now, Roger Penrose, again, we've heard of him already with Stephen Hawking, a very famous mathematician and cosmologist. Way back in 1979, I think it was, he wrote a book called The Emperor's New Mind, and in it he had this picture of the creator with a little pointer to this region of space. That's actually phase space. That's the space in which you plot all the states of a system in physics. And that defines the state of the system. And the state of the system that is our universe is only 1 point out of 1 in 10 to the 10 to the 123 possibilities. And so it looks like it's very unlikely to have been that particular state. But then it had to be some state, and so you can't just use a probability argument there. It could have been any one of those states if it's a random choice. And the argument that's made is if the constants of physics had been slightly different, life as we know it would not have evolved. That's the fine-tuning argument. It's also known as the anthropic principle. I'm sure you've all heard that. Now, I have a lot of quotations from people. Here's one from an astronomer, Edward Harrison, here he says that here is the cosmological proof of the existence of God, the design argument of Paley, updated and refurbished. The deistic design, the fine-tuning of the universe provides prima facie evidence of deistic design. Take your choice, blind chance, that requires multiples of universe, or design that requires only one. And there are many statements by both theists and many scientists of that nature. So let's look at the question of, does the universe seem to be designed for humans? Was the universe designed for life in general, or humans in particular? Well, first of all, the galactic space around Earth is not teeming with complex life. Earth is, in fact, the only known planet with life. Certainly none of the planets in our solar system have intelligent life. Maybe there's some primitive life at the bottom of some sea on some moon someplace, but certainly we haven't discovered it. We haven't discovered life on Mars. And even then it would be the most primitive kind of life. And the galaxy, the universe is huge, as I'm sure you know. It's a huge amount of wasted space. If the universe was designed for us, why would there be so much space out there? Let's just look at some of the numbers. The distances, of course, are immense. The nearest star, Proxima Centauri, is 4.2 light years away. The nearest galaxy is over 2 million light years away, Andromeda, which is shown in the background there. And there are galaxies, the galaxies within our horizon that are visible to us in principle are up to 40 billion light years away. And if you believe the inflationary model of cosmology, the universe began with the huge exponential expansion in the first 10 to the minus 35 seconds. It increased in size by many orders of magnitude. And so most of the universe is beyond our horizon. And how much of it? Estimates are that the universe beyond our horizon is 10 to the 100 times bigger than what's visible to us. I mean, an immense universe. Our universe, we think our universe is big, we think our galaxy is big. They are smaller than a grain of sand on the Sahara Desert. That's how much universe there is. And that's just our universe. There may be no reason not to believe there are many other universes as well. So why would God have done that all just for us? Hard to believe. It's also wasted time. The universe is, our universe is 13.7 billion years old. The Earth is 4.5 billion years old. And modern humans have been around for 150,000 years. Can everybody see those okay, or should we dim the lights? Is it okay? So humans have only been in the universe for 1,000th of 1% of the time that the universe has existed. And maybe we'll go on for another 2 or 3 thousandths of a percent before we're wiped out. The sun will eventually expand into a red giant that will engulf the Earth, and that'll be the end of life as we know it. And if you think we're ever going to go to other stars, forget about it. Forget about it. I mean, this whole business of thinking that humanity will be able to move off to the stars is totally impossible. We can't even leave the solar system without being killed by cosmic radiation. By the time we got out of the solar system, we'd all be dead. And that's only a few light years. So maybe our robots, our computers, will be able to survive, but humans, and the chances of us finding a planet exactly suited for us are infinitesimally small. Even if there are some lifelike, so-called Earth-like planets nearby, the chances that they would have all the properties that we needed to live is impossible. So. The other point is we tend to think the universe is a very orderly place. That's because we live in an orderly part of the universe. Actually, most of the universe is in random motion. Let's take the cosmic microwave background, which is shown here after much of it has been subtracted. This is just to show the fluctuations in it, which are 1 part in 100,000. So the cosmic microwave background, the photons in the cosmic microwave background, 1 billion times more numerous than the atoms in the universe. There's also neutrinos of the same amount. And they're all random to 1 part in 100,000. So the universe is quite random, and we happen to live in a tiny pocket of complexity. Now, you would have thought that an intelligent designer with special regard for humanity would have done a much better job, would have made it possible for life to live elsewhere than the Earth. Why couldn't he have had us live in space, be able to live on Mars? Certainly, an omnipotent God would have had that power. So, that seems very, very unlikely. It's time for my next joke. Thanksgiving just went by. I mean, not Thanksgiving. Thanksgiving's still to come. Halloween just went by, and there was this boy who decided he was going to dress up like Jesus, a Jesus costume. It didn't work out very well because the trick-or-treat candy kept falling through the holes in his hands. So, all right, I better stop there on the jokes. I have more, but nah. Trouble is, I'm telling these jokes to so many people now, I won't be able to use them again because you'll have heard them. Now, let's get into some of the more technical details on the fine-tuning claim. Let's first start with some obvious fallacies. The there are two constants, fundamental constants in physics: speed of light c, the speed of light in a vacuum actually, and Planck's constant h. And you will often read in arguments given by theists about fine-tuning, and believe me, you pick up any book practically written by Christians that talks about science. They give you the fine-tuning argument. Just walk into any bookstore, go to the Christian section, and pick a book at random, and you'll see this argument of fine-tuning. Okay, so the speed of light and h, if they had been slightly different, life couldn't have evolved, blah, blah, blah. That's what you'll read. However, if you know any physics, you know that they're just arbitrary constants. You could give any value you want because they just set the units in which you're going to measure things. If you're going to measure time in seconds and distance in meters, then you define c to be 3 times 10 to the 8th meters per second. If you want to use years as your unit of time and light years as your unit of distance, then c is equal to 1 light year per year. So it all depends on what unit you want. The same thing with h. It's an arbitrary number. Now there's some extreme examples that you'll find without which it is claimed any form of life would be impossible. Let me just go, there's only about 4 or 5 of them. The ratio of the number of electrons to protons in the universe, that is supposedly fine-tuned to 1 part in 10 to the 37. The ratio of the electromagnetic force to gravity is fine-tuned to 1 part in 10 to the 40. For example, if the two forces were equal, there wouldn't be any universe as we know it, because without gravity being weak compared to the electromagnetic force, the universe would collapse from gravitational attraction immediately. Gravity has to be pretty weak to keep the universe stable. The expansion rate of the universe is supposedly fine-tuned to 1 part in 10 to the 55th. The mass density of the universe, 1 part in 10 to the 59th. And finally, I'll mention the cosmological constant, which is a parameter in Einstein's general theory of relativity, cosmological parameter. 1 part in 10 to the 120. So this is what you'll read. Now let me mention, let's start with one of them, or a pair of them, by quoting the Christian apologists Dinesh D'Souza and William Lane Craig. They quote Stephen Hawking in his bestseller book, A Brief History of Time, which came out in 1988. On page 122, Hawking says, at least in my edition, page 121, if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have collapsed before it ever reached its present size. And that's an exact quotation from Stephen Hawking. And that's quoted, and then you'll find this quoted not only by these guys, but all the people who write, usually these guys who write, read William Lane Craig and then write what he says without questioning it. Now, both of these authors and the others ignore the rest of the story, because if you just go 7 pages later on page 128, pick up your book and look this up for yourself, Hawking says the rate of expansion of the universe in the inflationary model, he's talking about the inflationary model now, would automatically become very close to the critical rate determined by the energy density of the universe. This could then explain why the rate of expansion is so close to the critical value without having to assume the initial rate of expansion of the universe was very carefully chosen. In other words, inflation takes care of it. The inflationary model gives you exactly what's observed, and there's no fine-tuning necessary. Now, the other one is gravity and electromagnetism. I'm sure that you've heard this. If you ever heard a physicist talk, if you ever took a physics class, even in high school, I've certainly said it probably hundreds of times in my classes, and that is gravity is much, much weaker than the electricity, the electrical force. And that's based on the following calculation. You have an electron and a proton, and they're separated by a distance r. You can calculate the ratio of the electric to gravitational forces. Now I'm going to put an equation down here, and that's just for the aficionados, people who know equations. But basically, we can calculate the ratio of the force of the electrical force to the gravitational force. It's the ratio of the Coulomb force law and the Newtonian gravitational force law. The distance cancel out. They're both 1 over r squared laws, and you get this result. Depends on the charges and it depends on the masses. And so if you put in the charge of the proton and electron, which is the unit electric charge, and their masses, you put that in, you get the following number, 10 to the 39. So the electrical force is between an electron and a proton, no matter what their distance is, the electrical force is 10 to the 39 times stronger than the gravitational force. And of course, those are basic particles in nature, they make up atoms, and the universe, therefore, doesn't collapse immediately for that reason. And so that's where the 10 to the 39, 10 to the 40 fine-tuning comes in. But you see, it depends on the charges and the masses here. The charges are here, the masses are here. And if suppose we just put in some different charges and masses. Well, let's let the charges be the same for simplicity, the unit electric charge, but let the masses be equal to this number here. It's not important what the number is. Then you find the forces are equal. In other words, there's actually no universal way that you could define the strength of gravity. It depends on the masses involved. And so this puzzle, why is gravity so much weaker than electromagnetism, is not a puzzle at all. It's just because the masses are small. That's the actual real puzzle. The real puzzle is, why are the masses so small? And in the standard model of particles and fields that's been around since the 70s, and has agreed with all of the data so far, although the New Hadron Collider in Geneva hopefully will find deviations from it. Can't be right for all energies. Anyway, in the standard model, I don't want to go anywhere, I'm not going to speculate any further beyond what we now know, and what we now know is that in the standard model, all particle masses are intrinsically zero. And they pick up a small mass as a correction. So the reason the masses are small are simply that they're really fundamentally zero, and the mass that they have is just due to a tiny correction. And that's why they're small. And then that's why gravity is so much weaker than electricity. So it's amazing how many physicists aren't aware of this really simple fact. Now, the cosmological constant is the last one I'll mention. It appears in general relativity, and this is kind of an interesting one. It's assumed to be the source of the vacuum energy of the universe. That is, the universe is, if you take all the particles away, you still have it, and you have a vacuum, there's still energy in there, according to quantum mechanics. And so you can calculate that energy. And it's assumed to be responsible for the acceleration that we observed back in 1998, that the universe's expansion is accelerating. And you calculate the vacuum energy to have this value, 10 to the 115 GeV per cubic centimeter. GeV is 1 billion electron volts. So that's an energy density. And that's what you calculate. And then if you have, well, what is the value? Well, what is the true value of the energy? Well, it has an upper limit of 10 to the minus 5. So there's a difference of 120 orders of magnitude. Okay? So our calculation is off by 120 orders of magnitude. Now that is the worst calculation in the history of physics. It can't be right. It's obviously wrong. Why? Just ignore it. It's wrong. And that calculation now there are some physicists who still think, well, we have to have multiple universes to fine-tune the cosmological constant. Well, this calculation is simply wrong. Now, there are actually about half a dozen different possibilities that have been given for the scenarios that have been given for the cosmological constant value. And there's a new one called the holographic principle. Not new, it's been around about 5 years or so. And here's a tentative explanation. You take a sphere, the maximum information on that sphere that sphere can contain is proportional to the area, not the volume. That's why it's called the holographic principle. You lose a dimension. All the information is projected onto the surface of the sphere. No, I'm not going to try to prove it to you, but it can be proven. And if you use that and you calculate what the energy density is, you get exactly what is observed, or at least about what is observed, the order of magnitude. So that's a possibility. It's just tentative. It's still going to be argued over, and that's the way it is. So the extreme examples that I gave you about which it is claimed any form of life would be impossible are all have easy explanations. I didn't discuss this one, the ratio of electrons to protons, but that has a very easy explanation. It's just what it should be if you had charge conservation. The total charge of the universe is 0, which is what it should be if it came from nothing. In fact, that's what we'll find all along here. The universe looks exactly like it should if it came from nothing. So 0 charge came from nothing, and that means the ratio of electrons, protons, they have to be equal numbers. As simple as that. We just showed that the ratio of electromagnetic force to gravity is explained by the low mass of elementary particles. The expansion rate of the universe is explained by inflation. The mass density of the universe is also explained by inflation, and the cosmological constant has a tentative explanation. And as long as we can provide a plausible explanation for anything, you can't assume that there has to be a creator until the God of the gaps argument requires that you prove that there's no answer to the gap in our knowledge other than God, and no one's ever been able to do that. So no fine-tuning is necessary. Let me just quickly mention some of the other parameters that are not that crucial. A lot of calculations have been made, including one of my own that goes back to 1995, and is published in my book, The Unconscious Quantum, is that you can vary the constants by quite a bit and still get some form of life possible. Yes, I agree that our form of life depends very much on the values of the constants, of the parameters that we have, but other forms of life are well within ranges of variations. Only those 5 that I mentioned would prevent any kind of life being possible, and they're explained. So that takes care of fine-tuning. Let me give you a summary of that part. The claims of fine-tuning are based on inadequate understanding of the physics involved and incorrect analysis procedures. For example, one of the things that people do that's absolutely wrong is they hold one constant, they vary only one constant and hold all the others, let me say parameter rather than constant. They hold all the parameters constant except one, they vary one, and that's absolutely incorrect procedure. You have to vary all of them because some can compensate for others. So that's an incorrect procedure. Some parameters have the value they do by definition. Some parameters have exactly the values they have based on standard models, so physics and cosmology. And the remaining parameters are not fixed by standard model, have values within the range expected by those models. So my conclusion is that only the cosmological constant remains plausible. So, this thing keeps falling off here. The universe shows no evidence of being designed with humans in mind. Now, let me move on to the next topic, which is quantum spirituality. Now, this actually goes back quite a while, but it became noticeable again 3 years ago with the film The Secret and the books that came out with it, as well as another film called What the Bleep Do We Know? And the theme there of The Secret is that quantum mechanics teaches us that we can be what we want to be. All we have to do is think it. You just have to think about it. So you can be beautiful, you can be rich, you can live forever. You can be anything you want just by thinking it. Guaranteed to work, they tell you. It's guaranteed. You read what they say. So let me give you some of the history there. The quantum mysticism goes back, as I said, to 40 years ago or something like that, or 30 years, to 1975. That's 35 years ago. With the Tao of Physics, which it was written by the physicist Fritjof Capra, in which he claimed there was an essential harmony between the spirit of Eastern wisdom and Western science, and that kicked off what became called the New Age movement. And the gurus of that New Age movement, in addition to Capra, included Maharishi Mahesh Yogi, the founder of Transcendental Meditation. He was a physicist by training, believe it or not, and he started that movement. He's dead now, but the movement still goes on, and they will tell you that there's a universal field, unified field of intelligence that pervades the universe, and they again use quantum mechanics to claim that. The other guy that's still around is Deepak Chopra. He's written a lot of books, but these are the two ones that bear on this issue. Back in 1989, he wrote Quantum Healing, Exploring the Frontiers of Mind-Body Medicine. Quantum was in the title. And the other one, 1993, Ageless Body, Timeless Mind, the Quantum Alternative of Growing Old. And so he told us that by following his teachings, you won't grow old. And there he is as he looked in 1993, and here he is. Here he is today. So he hasn't been thinking hard enough. Well, where does it all come from? This looks a little complicated, but it gives the basic idea. I'm sure you've all heard of the double slit experiment. It was a double slit experiment that Thomas Young, back in 1800, demonstrated the wave nature of light. And here you have an electron gun or a photon gun. You have photons or particles of light. You send them through two slits, and you have some detectors over here on the wall. And when both slits are open, you get a interference pattern that looks like this. Easily demonstrated with a laser these days. I used to do it in my classes all the time. If you close one slit, you get this, either this distribution or that distribution, depending on which slit you leave open. And the statement is that if both slits are open, you have a wave, because that's a wave interference effect that you see with water waves, for example. And if one slit is open, you have a particle. So it seems to be this is a wave-particle duality. And it would seem that the nature of reality seems to depend on what you decide to measure. If you decide to measure a wave property, then it's a wave. If you decide to measure a particle property, then it's a particle. And this is the whole basis of quantum spirituality, that we make our own reality, because it seems like quantum mechanics is telling us that you could decide on the reality of an object, the nature of an object, just by deciding what to measure. And much misunderstood. Let's do the experiment with individual photons, where we have a detector that on the screen, that a whole array of detectors that can detect at the one photon level. We have such detectors today that can detect individual photons. In fact, our eyes even come pretty close to detecting individual photons. So it's not hard. So we start out with the first few hits, and you see something that looks more or less random. Both screens are open, both holes in the screens are open, both slits in the screens are open. As you build up the hits, you find that a pattern is beginning to emerge, and when you get a lot of them, there's our interference pattern. Okay, what does this mean? It means that particles are being observed even when you're doing the double slit experiment, which is supposedly designed for measuring wave-like properties. You still observe individual localized particles, whether you have one slit open or two slits open. And what the interference pattern is actually statistical. It only appears when you have a lot of photon hits. It only appears statistically. And this is what quantum mechanics says, that the quantum effects are described statistically by the wave function. So that's one thing that indicates there are particles, there's no particle duality, that the wave description just involves the statistical effects. Now, again, for the more technical of the audience, those of you who are engineers, for example, would be well familiar with the Fourier transform. And you know that in the Fourier transform, if you have a position, or you have, say an electrical signal, and it's well defined in time, well defined in space, in position, you can do a Fourier transform. It's a mathematical transformation from a function of position or time to a function of frequency. And so you would say, here's a localized particle. It has all kinds of frequencies. So you wouldn't just want to define that as a wave. You'd want to define that as a particle. So this is a particle, and this is a wave. Now, if you have the other situation where the frequency is well defined, for example, when you have a sine wave, then you would call this the wave and this the particle. So it depends, again, on what you decide, how you just want to describe it. But the point is, and I'm sure all of you who know about this, that it's the same phenomenon. The same electrical signal could be described either way, as a particle or as a wave. They're just two different ways of describing the same phenomenon. And the wave-particle duality is just, it has to do with two different descriptions of the same property, not two different realities that you're changing by your consciousness deciding what to measure. Okay, so then what are the answers, I'm winding up here, to the theist and spiritualist claims? Here are the claims again. The eternal universe is mathematically impossible. Well, as I've argued, the eternal universe is mathematically possible. The universe began with a singularity. The universe did not begin with a singularity, for sure. The universe is fine-tuned for life. No, the universe is not fine-tuned for life. And here I'll make, since everybody who talks plugs their books, I'm not going to avoid that. Here's the next book coming out, The Fallacy of Fine-Tuning. Be out next spring. And incidentally, I'll be signing other books out there. The lady from Borders is here and has my books available, some of them. Finally, quantum mechanics says that we can make our own reality. No, it doesn't. Quantum mechanics does not say we can make our own reality. So I'll end with the picture of I started out with. This is the Large Hadron Collider in Geneva. It's a tunnel 17 miles long, containing superconducting magnets, experiment that probably cost $1 billion to build. Remember one time we were going to have the superconducting super collider, but that was canceled by Congress. And this is that was even going to be bigger than this. It was going to be built in Texas, and it was canceled. But so the U.S. has some involvement in this, but it's a international effort. And the data is starting to come in, and really it's beginning to look promising that the preliminary data is already deviating from expectations. So I think finally, after having the standard model for 30 years, we're finally going to be able to move on to the next level of understanding. And believe me, it's very unlikely that we're going to turn up anything remotely connected with the idea of spirit. So thanks very much.